All right, so this is the last video that we will go through in Chapter 8 before our next test, and that's going to be Section D, and we're only going to talk about parallel and perpendicular lines, and we're going to keep this really basic for this. So we're going to talk about parallel and perpendicular lines, and what you need to know is you need to know our objectives. You need to know what parallel and perpendicular lines are. Right? What are parallel and perpendicular lines? And then the other thing you need to know is how to find the gradient or slope, remember they're interchangeable, of a line that is parallel or perpendicular to another line that is given. All right, so I will give you a slope of a line and say, what is a parallel or perpendicular line slope to this given slope? And you have to be able to figure it out. It's really simple. All right, this section is actually probably the easiest of the four that we have done in Chapter 8. So let's go ahead and get started on this. And we're going to talk about parallel and perpendicular lines. All right, so first we need to know what parallel and perpendicular lines are. And it's describing a relationship between two lines. So if I draw two lines, I'll draw a black one and I'll draw a red one. Right? If these lines, even if I extend it to infinity, because that's what the arrow means, even if I extend it to infinity, they never touch, they never intersect, they never cross over, then they are parallel. Right? And the way that we can let readers or people know that lines are parallel is by drawing these arrows on the line. If you see these arrows on the line, that means that those lines are parallel. All right, so that tells me that they're parallel. And parallel lines, they never intersect. So a parallel line, two parallel lines will never, ever, ever touch. They'll never cross over. They'll never intersect. All right, so parallel lines will never intersect. All right, now the next type of parallel, or the next type of line, so that was A, let's just say that's parallel lines. So for B, we will talk about perpendicular lines. And perpendicular lines do intersect. So they intersect at one point. So the lines only intersect one time. They only cross over one time. And the intersection forms a right angle. And remember, a right angle means it is 90 degrees. So if I draw this blue line here, and I tell you that the black line is perpendicular to it, so it intersects at one point and one point only. And at this intersection, we can go ahead and write a right angle. All right, we can actually write a right angle for all four of these angles. So when two lines are perpendicular, they intersect at one point and one point only, and they intersect at a right angle. All right, so that's the difference between parallel and perpendicular lines. Parallel lines never intersect, they never touch. Perpendicular lines do touch one time, and when they do, they intersect at a 90-degree angle. All right, so these are some very important characteristics that you'll need to know not only just this year, but in your upcoming years in math. All right, now, there's one thing I want to talk about in particular with perpendicular lines. So if I tell you the slope of one line is equal to 4, and I ask you to find the slope that is perpendicular to the given slope. So if I tell you that the slope we have is 4, find the slope that is perpendicular to that. The other rule that you need to know about right angles or about perpendicular lines is their slopes are negative reciprocals. All right, so what that means is if we're given a slope and we want to find a slope of a line that's perpendicular to it, we first need to take the reciprocal. So the reciprocal of 4 is 1 over 4. So I know that my perpendicular slope is going to be at least 1 over 4. And then it says the negative. Sometimes you'll also see books write it as the opposite reciprocal. All that's saying is we're changing the sign. If it was positive to begin with, we're now making it negative. Right? So this 4, if we have a slope of 4, its reciprocal slope is negative 1 over 4. So if I give you a slope that is, say, negative 3 over 2, and I ask you what is the slope that is perpendicular to this? Well, first we take its reciprocal. So it's reciprocal, we flip it. You say you love me, now you're flipping like reciprocal. So it becomes 2 over 3. And then we're taking the negative of it. So since it was negative to begin with, this perpendicular slope is positive. Right? And one of the things that you can do to check your answer is if you multiply your two slopes together, 4 times -1/4, it must equal -1. So that does, and -3/2 times 2/3, it must equal -1, which it does. All right, so with perpendicular lines, we need to know that they intersect at one point and it forms a right angle, and then we also need to know that their slopes are negative reciprocals. That's how we solve for them. All right, I didn't tell you about parallel lines, so let me go ahead and tell you that now. So they never intersect, and their slopes are equal. So that means if I tell you that the slope here is equal to 3, and I say, what is the slope of a line that is parallel to 3? It is also 3. If I tell you that our slope here is equal to -1/5, and I say, what is the slope of a line that's parallel? It is also -1/5. All right, I apologize for not doing that with the parallel lines earlier, but parallel lines are equal, perpendicular line slopes are negative reciprocals. All right, so let's go ahead and solve some questions with this. All right, it says a line L has gradient 2/5. Find a gradient of any line which is parallel and any line which is perpendicular. So remember, parallel lines have equal slopes or gradients. I'm sorry, I'm just used to saying slopes. But parallel lines have equal slopes, and perpendicular lines have negative reciprocal slopes. All right, this is what you need to remember. All right, so now let's go ahead and answer this. So for A, we want the slope of a line that is parallel to line L. Well, if the slope or gradient of a line is 2/5, that means this slope that is parallel to it has to be the exact same because parallel lines have equal slopes. So it must also be 2/5. And then if we want a line that is perpendicular to L, remember, it is its negative reciprocal. So the slope will first have to be the reciprocal. Well, you say you love me, now you're flipping. So you flip them like reciprocals. So it's 5/2, and then it's the negative reciprocal. So we have to take the opposite sign. So its negative reciprocal is -5/2. And remember, if you want to check your work for perpendicular, you can multiply the original slope, 2/5, times the perpendicular slope, and it must be equal to -1. And if it's not, then it's not correct. All right, now this problem here is wrapping up everything that we have done so far in this chapter. All right, in this chapter 8. It is going over everything. So this is a really good example. So it says, consider the points A, B, and C. Show that triangle A, B, and C is isosceles. So remember, the first thing we do is we draw this triangle off to the side. And since we're just sketching it, it doesn't have to be exactly graphed to scale. And in order to show that it's isosceles, we then need to find the distance of AB, BC, and AC. Right? So that means I'm going to find for A, the distance of AB. And then for AB, that means I'm going to use the points A, 1, 0, and the points B, 2, 4. I'm going to label them. This is x1, y1, and x2, y2. I am then going to plug it into my distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. And the distance AB is equal to this. All right, then from here, we're going to substitute in what we know. Well, AB is equal to 2 minus 1 squared plus 4 minus 0 squared. Well, then the distance for here, this is going to be 1 squared plus 4 squared, which is going to be square root of 1 plus 16. So AB is equal to the square root of 17. So I know that this is equal to the square root of 17. We would have to do the same for this one here and find the distance of BC because we need to find a distance for all of them. So we're going to find a distance from 2, 4 to 5, 1. All right, I'm going to do this one really fast. X1, Y1, X2, Y2. So then from here, it is going to be 5 minus 2 squared plus 1 minus 4 squared. So it's going to be 3 squared plus -3 squared, which will then be 9 plus 9, so the square root of 18. Remember, since we're not actually finding the real distances here, it's okay if you don't simplify it because They didn't ask us to find the actual distance. They just said show that it's isosceles. All right, now I'm going to erase this, and then I'm going to go ahead and do the last one that we need to do. So we need to then find a distance of CA. So we're finding the distance from points 1, 0 to 5, 1. So this will then be x1, y1, x2, y2. Remember, you can label them any way you want. It doesn't matter. You don't have to do the same x1 and y1s that I did. 5 minus 1 squared plus 1 minus 0 squared. So this will then give me 4 squared plus 1 squared, which is 16 plus 1, or let me erase this down here. Or the square root of 17. So we know that this is the square root of 17. Right now, we just showed that this is isosceles because we showed that we have two sides of this triangle that are equal in distance, right? Two of the sides of this triangle are both the square root of 17. So check, we just showed number one, or A, that the triangle is isosceles. We then need to find a midpoint of BC. So if we're finding the midpoint of BC, we're finding the midpoint of 2, 4 and 5, 1. All right, so from 2, 4 to 5, 1. So I will then label this x1, y1, x2, y2. Then our midpoint is equal to 2 plus 5 divided by 2 and 4 plus 1 divided by 2. This is then going to be equal to 7 over 2 and 5 over 2. Remember, make sure that you are leaving this in parentheses. So there is our midpoint, M. So we know the midpoint, M, that they asked us to find for BC has a midpoint of 7, 2, and 5 over 2. All right, it tells us to use the gradients that AM and BC are perpendicular. So what that means then is we need to find the slope because we're trying to find, see, is AM perpendicular to BC? So what we need to do then is we need to find the slope of AM. Well, we know A has points of 1, 0. We know M has points of 7 over 2 and 5 over 2. So we'll find the slope. So we know that our slope is equal to y2 minus y1. So x1, y1, x2, y2. So it'll be y2 minus y1 over x2 minus x1, which is then going to be 5 over 2 minus 0 over 7 over 2 minus 1. So this will then be 5 over 2 divided by 5 over 2. And we know 5 over 2 divided by 5 over 2 is equal to 1. So our slope of this is equal to 1. All right, if you were confused with this one, I'll explain that step a little bit more in class. That part might have been a little bit trickier since it was a fraction as fractions within a fraction. But then the next one we have to find is the slope of BC. So B is 2 over 4 and C is 5, 1. So we just label them x1, y1, x2, y2. So our slope is equal to y2 minus y1, so 1 minus 4 over x2 minus x1, 2 minus 5, which is negative 3 over negative 3, which is equal to negative 1. So this slope is equal to negative 1. So to see that they are perpendicular, we need to ask ourselves, is 1 and negative 1, are they negative reciprocal slopes? Or multiply them together. Does 1 times negative 1 equal negative 1? Check. So since it does, we showed that they're perpendicular. All right, that is it for this video. I know that this question was a little bit longer. We'll go through one again in class.